In the last videos, we discussed about how do we solve a second order non-homogeneous differential equation with constant coefficients when the right hand side function, which is the external force function, right, is continuous. Also, we discussed about when the external force is basically when the right hand side force or the external force is discontinuous. Okay, so here we are going to talk about section 5.7, which is the impulse function. So impulse function, meaning that we will have on the right hand side the gt function. On the right hand side we will have impulsive force, meaning that you apply the force, big force, for a very short period of time and then you stop it. Okay, for example, in the spring mass system, if you are hanging a mass at the bottom of the spring, and if the spring is fluctuating or the oscillating, and if you apply a hammer, if you hit the spring by a hammer just once, okay, with the big force and just for one time point, and then you stop it. Okay, so how do we handle that type of problem? Okay, so to handle that type of function, we first define a function which is called Dirac delta function. Okay, so we denote by delta t. This is called the Dirac delta function. Okay, so how do we define the Dirac delta function? Is at t equals to t0, the function takes infinite value. Okay, or indeterminate value. Use value or infinite value, and 0 everywhere. Okay, so you have a 0 and then you have a spike. Okay, and then again 0 everywhere. You see that? So at the point t equals to t0, there is a spike. You see that? And then other than t equals to t0, it is 0 everywhere. Okay, so but what we want extra thing for the Dirac delta function is we want the integral over any interval that includes t0 is basically 1. Okay, that's what we want. Okay, so let us write what we want. So that is the thing that we just mentioned can be written as delta t minus t0. Okay, is equals to 0, meaning that other than t0 the value is 0. Okay, other than at t0 the value is 0 for t not equals to t0. This is one thing. Also, the other thing that I just mentioned is the integral of the Dirac delta function at any point or at any interval that contains t0 is also 1. So that means you can write t0 minus epsilon to t0 plus epsilon delta t minus t0 dt equals to 1. Okay, and if you have t0 minus epsilon to t0 plus epsilon delta t minus t0 times f of t, that will be just f at t0. So in these both cases the epsilon is a small quantity which is positive. Okay, what does that mean? This means the delta function is 0 everywhere except at t0. Okay, So at any interval containing t0, that interval can be small or big, okay, the value of the integral of the delta function is 1, okay, and if you have multiply the delta function with a function ft, and if you integrate that product in the interval t0 minus epsilon to t0 plus epsilon, then the value will be f of t0, okay, which is same as the value of the function at t0. So these are the properties that holds by the delta function, okay. So the last two properties holds true for any interval containing t0. That's what you get, okay. So now how do I find out the Laplace transform of the delta function? Okay, how do I do that? So the Laplace transform of the delta function, you write Laplace transform of delta t minus t0, okay, which is same as 0 to infinity, right, and then e to the negative st, and then delta t minus t0, and then dt. You see that? So what is the definition of look at the third property of the delta function. If you are multiplying the delta t minus t0 with any function, then which is the integral will be any integral, okay, for any interval, right? Integral that contains t0, any interval that contains t0, the integral of the product is same as the f at t0, the other function at t0. So which will get e to the negative st0. You understand that? Where t0 must be greater than 0, right? That t0 must fall in that interval. That's what it says. If t0 equals to 0, then what do you get? This function will be Laplace transform of delta t, right? So this will be how much? 0 to infinity, you will see e to the negative st times delta t, right? dt. Now you apply the same thing again. So t0 is 0, right? So that will become e to the negative s times 0, right? Because the t0 that will be replaced by t0. So which will give you 1. So the Laplace transform of the Dirac delta function is 1. The Laplace transform of Dirac delta function with at t minus t0 is e to the negative st0, okay. So now we'll use this concept to solve a differential equation with impulsive forcing function, okay, meaning the right hand side function is a function of delta function, okay. So let us see some examples. Example is solve the initial value problem. It is given as y double prime plus 4y equals to delta function at t minus pi, and then plus delta function at t minus 2 pi. Delta function at t minus 2 pi with the initial and the boundary initial condition as y at 0 is 0, and then y prime at 0 is also 0. So how do I solve this Laplace transform? How do I solve this equation using the Laplace transform is we take the Laplace transform on both sides, right? Now on the left side, so this value is how much? This value is 0, right? And this value is 0 as well. So what you get is s squared plus 4, right? And then Laplace transform of y. Because you combine the Laplace, these two terms, so you take the Laplace transform of y outside, is equals to, you will get e to the negative pi s plus e to the negative 2 pi s. You see that? Now how do I solve it then? So Laplace transform of y equals to how much? You get e to the negative pi s over s squared plus 4 plus e to the negative 2 pi s over s squared plus 4 as well. Now what we do next is we take the inverse Laplace transform on the both sides. Okay, guys? So we know that inverse Laplace transform e to the negative cs times f of s is equals to uct times f at t minus c. So you see that there is, instead of c, there is negative pi, right? And then there is times f of s. So f of s is the Laplace transform of the function ft. So which function has the Laplace transform 1 over s squared plus 4? Basically that will be sine, right? So that will be basically the sine. So what you can do here is inverse Laplace transform of a over s square plus a square is equals to sine at. We know that formula, right? Now look at here. So for this function, you can write uct times f of t minus c, the inverse Laplace transform of that, right? But we have, what is that fs? It looks like that is fs, right? If you have that fs, the inverse Laplace transform of that one will be sine at, right? Look at here, what do we have? When you take the inverse Laplace transform of this one, then you will get, so it will be uct will be u pi and then t, right? And f at t minus pi. So what is f? That will be sine, right? You can think that as ft. This is like fs, right? You see that? This is like fs. You get that one. Now you get inverse Laplace transform of e to the negative pi s over s squared plus 4 can be written as u pi t times f of t minus pi. You see that? You get f of t minus pi. Now what is f of t though? Because the inverse Laplace transform of a over s square plus a square is sine at, but we don't have a over s square plus a square. We have just 1 over, right? So we will need 2 on the top, so I will do 1/2. You can write u pi t times 1/2 sine a, but t should be replaced by t minus pi, right? T minus pi. That's what you can write. So t minus pi. Similarly, the other one will be u 2 pi t and then 1/2 sine a t minus 2 pi. Hence, the final answer is taking the inverse Laplace transform, taking the inverse Laplace transform of a, we get, you write yt on the left side, on the right side you will write u pi t times 1/2 sine a t minus pi plus u 2 pi t times 1/2 sine a minus 2 pi. That's what you get. That is the final answer. Okay. Let us look at another example. That says solve 2y double prime plus 10y equals to 3 u12 t minus 5 delta t minus 4, and the initial condition are u0 is -1 and u prime of 0 is -2. Okay, so to solve this we take Laplace transform, right? Take Laplace transform. We get s square, there is 2, right? Laplace transform of y minus 2s y of 0 minus 2 y prime of 0 plus 10 Laplace transform of y equals to, now we need to find out the Laplace transform of y12. So how do I find out that? U12. So what is the formula? Laplace transform of uc f of t minus c is given as e to the negative cs, and then Laplace transform of ft. This is the formula we learned in the previous sections, right? Now we have u12. So how do I do that? You can write, you replace c by 12. You will get u12 f of t minus 12 will become e to the negative 12s, right? Times Laplace transform of f of t. Now, if you compare these with that one, what do you get? Is f of t minus 12 is equals to what? 3, right? So what is f of t then? It is also 3, because if you replace t by t plus 12, you will get 3. So what is the Laplace transform of 3? This will become negative 12s, and then Laplace transform of 3, right? That will become 3 over s, because the Laplace transform of a number is that number over s. So it will be e to the negative 12s over s, and then you can write that 3. So 3 over s times that. Similarly, what is the another formula? Laplace transform of delta t minus t0 is equals to e to the negative st0. That's what we learned, right? So in that way, what is the Laplace transform of delta t minus 4 then? That will be e to the negative 4s. That's what I got there. So 5 is already there. So this is what I get for the Laplace transform of the right hand side. So what do I do next is I want to plug the value of y0 and y prime of 0. Okay. And then we simplify it. Okay. So what do you get here? It is 2s times negative 1 will be positive 2s. You see that? So you will get, and also you see that this one and that one has Laplace transform in common. So I'm taking that thing out. Okay. So I'll write 2s squared plus 5 Laplace transform of y. Okay. And then plus 2s plus 4 equals to 3 e to the negative 12s over s minus 5 e to the negative 4s. You see that? Now let us move these to the right hand side, and then we will divide by that. So you get 2s squared plus 5 Laplace transform of y equals to negative 2s minus 4 plus 3 e to the negative 12s over s, and then minus 5 e to the negative 4s. Okay. Now, I want to divide both sides by 2 times s squared plus 5. What do I get? I get Laplace transform of y equals to negative 2s over 2s squared plus 5. I'm dividing each term, okay? Minus 4 over 2s squared plus 5 plus 3 times e to the negative 12s times 1 over s squared plus 5. You can write 3 half because we are dividing by 2 times s squared plus 5, right? And then minus 5 half e to the negative 4s times 1 over s squared plus 5. This is what I got. Okay. Now, you see that except this term we will need partial fraction. When you take the inverse Laplace transform, you will need the partial fraction of that. And for other terms, it will be the straightforward, right? Because there is, you see that, s over s squared plus 5. It will be cosine, right? This will be sine 1 over s squared plus 5. And this will be sine as well. But there is e to the negative 4s. So we will have the answer in the form of u, right? So we will do that later. But for now, let us do the partial fraction. You will get 1 over s times s squared plus 5. If you use the partial fraction pf, partial fraction pf, if you do the partial fraction for that, so what do you get? You basically get 1 over 5s, 1 over 5s minus 1 over 5s over s squared plus 5. This is what you will get if you do the partial fraction. Okay. 1 over 5, you can take that out and then just do s squared plus 5 minus s squared. So s squared will cancel out. So if you combine this, you will get exactly the same thing using the. So this is basically from the partial fraction. Okay. Let us write that. So you got Laplace transform of, let me use that color. So okay, so Laplace transform of y equals to, so let us cancel this, that is 2, right? And then all other things will stay same, so it will be negative s over s squared plus 5 minus 2 over s squared plus 5 plus 3/2 e to the negative 12s times, that thing is basically, you can take 5 out. Let's take 5 out. So it will be 10, right? 3 over 10. So you will get 3 over 10 there. 3 over 10. And then 1 over s minus s over s squared plus 5. This is what you get. And then minus 5 over 2 e to the negative 4s times 1 over s squared plus 5. Now we take the inverse Laplace transform on both sides. Okay. So how do I do that? Is take the inverse Laplace transform, and also when we use the inverse Laplace transform, I want to use this formula. So inverse Laplace transform of e to the negative cs fs is equals to how much? So the formula is uct times f of t minus c. This is the formula, because we will need that for this term, for the other term, and for that term, right? So let us see. Okay, when you take the Laplace transform of this equation star, then we will get yt equals to, now you take the Laplace transform of inverse Laplace transform of that will be negative, what do you get? Negative cosine, right? Because that one is just straightforward. So you'll get negative cosine, because the Laplace transform of cosine at is s over s squared plus a square. You see that? S over s squared plus a square. But here is s over s squared plus a is root 5, right? A square is 5. So cosine root 5 t. You see that? That will be cosine root 5 t. Now, what is the inverse Laplace transform? Negative 2 over that. That will be sine, right? Minus sine. Oh, there is 2. But you see that you will need a over a square plus s square plus a square. But a will be root 5. We don't have root 5 there. So you multiply and divide by root 5. So you will get 2 over root 5. You see that? Sine root 5 t. That is for the first two terms, right? Now, how about these two? Let me write down those two terms as these terms as it is. Okay. So what you get is basically 3 over 10 and then inverse Laplace transform of e to the negative 12s times 1 over s, right? And then minus 3 over 10 again, inverse Laplace transform of e to the negative 12s times s over s squared plus 5. And the last one is minus 5/2 and then inverse Laplace transform of e to the negative 4s times 1 over s squared plus 5. You see that? This is what you get. Now, the first two terms will copy the same thing. We'll copy the same thing for the first two terms. Now, for this term, that is plus, right? So plus 3 over 10. What is the inverse Laplace transform of that? You see that inverse Laplace transform e to the negative cs fs. The fs is uct. That will be e to the, u12t. So inverse Laplace transform 1 over s is 1, right? So that will become just f of t minus c will be just 1. Minus 3 over 10, right? And then u12t So what is the inverse Laplace transform of that? That will be cosine AT, right? Cosine A means root 5 because this is A square, right? So it will be cosine root 5, and then T will be replaced by T minus C. You see that? T will be replaced by T minus C, but C is 12. So it will be T minus 12. That's what it looks like. And the last one is negative 5 half. So that will be U 4T times the inverse Laplace transform of this is sine, right? But we need 1 over root 5 times root 5 over that thing, right? So it will be sine root 5. T will be replaced by T minus C, right? It will be T minus 4. Okay, now what we do is you will combine these two, and then you will get basically the last term can be written as basically the last term only. Okay, the other term will be the same. The last term will be negative 5 over 2 root 5, and then U4 T times sine root 5 T minus 4. That is the simplified form of the last term only. So that is the final answer for this. Okay guys, so this is the end of section 5.7. so the homework problems are section 5.7, question number 1, 3, 4 and 5. Okay guys, so try to do those problems.